first off, very annoyingly, I realized that I lost my stylus for my pad, so I won't be able to write anything. I have an extra one in my office. Maybe at break I'll go back and grab it. So also the first time it's ever happened since I've been here a while. But no worries. What we'll do is actually I'll just show you the notes from last class. I'll go very slow so that you can make a copy of it. It might actually even work better. I don't know. We'll try it. And if it's really annoying at break, I'll go back to my office and I have an extra one. And if it works okay, then we'll just do it for the rest of today's class. And then next class, I'll make sure I have a extra. I should always have a couple in my bag. But. Okay. Before we start, is there any questions from last class? Yeah.
If you don't mind, you can use this one.
Oh, sure. Let me try it. Thank you. You're too good. I don't know if it will work, but it's this isn't. Yeah, sorry, it doesn't. It's not an Apple thing. Mine. Sorry. Anyone else have a clever idea? I don't know how it works. I assume that it's magnetic or something. I can just try a pen, but I don't think it's going to work. Yeah. Anyways, it's proprietary technology. Okay. So are there any questions from last class? Yeah. Go ahead.
Let's say that a CA which authorizes other certificates.
Yeah. Actually, just give me a second. Let me close the door. Okay, sorry. Go ahead. A CA authorizes.
An intermediary CA which authorizes new certificates.
Yeah.
So does all the certificates in the past that the CA issued are revoked also?
So it depends on the reason why it's being revoked. So if the website certificate, like say there was a misissuance of it, or the website lost their key or something like that, they might ask for the website certificate to be revoked. In that case, the issuing certificate authority would do the revocation. So the one that's closest to them in the path, they're the ones that are going to advertise that it's revoked, and it's only going to revoke that site certificate. And then the other reason that a certificate might get revoked is actually a CA is breached. So that's happened on occasion, like not very often. In that case, the parent CA would revoke the CA certificate. And once that CA certificate's revoked, everything that it signed is also not going to trace back, right? It's not going to chain back correctly. Or it will chain back, but it's going to go through a revoked CA. So effectively, it revokes all of the site certificates that were also issued from it. Yeah. So you pick a point along the chain where you revoke, and everything downstream is going to get revoked with it. Yeah. But anyway, CAs usually don't get revoked. And if they do, it's a big enough deal that often the operating system or the browser will push a software update and put that revocation in hard code, as opposed to just relying on the revocation mechanism. Other questions?
So OCSP is being implemented because it works faster than CRL, or what's the...
Yeah, so the history of it is that we started with CRLs, and the problem with the CRL is that you download it, and then there's basically a question of how often should you refresh your CRL. And remember, you're refreshing it for 200 companies around the internet, right? And so if I do it today and then say I do it every 3 days, then if a certificate gets revoked in between, then I don't learn about it. And so I could, every time I connect to a website, right, that I could say, here's the CA that it looks, I could go ask for their revocation list. But now the problem is I'm downloading a list that involves a whole bunch of certificates rather than the one that I'm interested in. And so then the thinking was, okay, you should actually ask every time you connect, but why don't you ask just about the certificate that you're interested in, and then you don't have to download this big list. And so that's how we ended up with, OCSP.
Basically reducing the overhead data.
Yeah, exactly. So it's more frequent, but less, it's a more specific request. So Now you could maybe find some middle ground, like these aren't the only two options in the world, but that was basically it. So CRL is infrequent large data, OCSP is frequent small data. Yeah. And then what Google's trying to do is a kind of middle ground where they're trying to aggregate all the CA stuff, push it to the operating system, to the browser, and they have some, they throw a lot of data science at it, like to get the data structure so it's really lightweight. Even though you're getting a ton of information, you're not getting it as a list, you're getting it as this like Bloom filter thing, and you basically take a hash of what you have, and you run it across this filter, and it will either say true or false, and it's very compact. But yeah, not as compact as an OCSP response, but definitely more compact than getting like a .crl file, like the one on the screen. Other questions? Okay. All right. So let me try and find the right spot in the notes from last year. Yeah, so one other point that maybe I didn't emphasize strongly enough, but I should maybe draw attention to it, is the revocation does have to happen by the CA that issues the certificate. And that seems very obvious when you think about it, but let's think through the ramifications. So let's say that you're Google and you use yourself as your CA, and then there's some CA out in the world that gets breached. And they're the ones that issue a Google certificate. Okay, now Google's like actually very well positioned because they have one of the most popular websites and they have one of the most popular browsers, right? So lots of people are going to the Google website from a product that Google controls. And so Google does a lot of experimentation because they're in that position. And so one thing they started doing is they would hard code the certificates for Google in Chrome itself. And if you ever went to Google and you got back a certificate that is not the same, but is still legitimate, then that person's Chrome will phone home to Google in Mountain View and say, hey, look at what I just found in the wild. So they turned this on, and within a couple months, we already found 2 certificate authorities that were breached and were misissuing Google certificates. So then what happens is Google realizes, okay, there's this company like DigiNotar was one and Komodo was another. So there's this company in, let's say DigiNotar, they're in Netherlands. It's a small CA in Netherlands, and they're issuing Google certificates. That's the CA that needs to do the revocation, right? So Google can't go to their own CA, the CA that they have a business relationship with. They have to go to some stranger, right, and say, oh, you messed up. You issued a certificate for my resources. They obviously weren't confident enough, because they misissued the certificate. Now you have to rely on them to be the ones that are going to do the revocation. So that's a little problematic that revocation has to be done sort of by the CA that screws up. And so, yeah, so anyways, that's another downside to revocation. Okay. All right, I'll just give you a second to write this down. Okay, so another option that you can do that's very simple, and I think we actually sort of alluded to this, is that you could, okay, so we described one thing, which is you could just use the wrong certificate, right? So there was an example of Syria Telecom, and they just dropped in the wrong certificate. Another thing you could try to do is not use a certificate at all. So you don't have to use a certificate if you're on HTTP, right? It's only when you switch to HTTPS that you need to start using your certificate, okay? And so there's different ways that websites work, and this is a kind of bad template that lots of websites did until very recently. I would say until maybe 2-3 years ago, people started realizing that this was problematic. I used to give the example of the New York Times, but they've since modified. I should probably find a website that still does it this way. But generally, this is what it would look like if you go to a website. You go to a website like a newspaper website, and you would go to it over HTTP. Okay, so you're on the website, it's in HTTP. Then they might have so this is called the front page or the loading page. It comes to you, so you ask for it, it comes to you over HTTP. Then at the very top of the website, they might be like, okay, do you want to log in? Right? And there'll be a field there for your username, and there'll be a field for your password. So that's fine. So you put your username and your password, and then you press submit. Okay? Now what happens when you press submit? This is a website that came down to you over HTTP. Okay? So ideally, when you press that button, you want it to submit the password over HTTPS. So at that point, it should switch to HTTPS, right? So that's fine. And now, here's a couple of questions. So the first question is, how do you know as a user whether that password's going to go over HTTPS or not? Right? And so the answer is you don't. I'll just show you, let's pick, I don't know, Montreal Gazette and see. Even if it's over so yeah, now they all go over SSL. But let's just pretend that this came down over HTTP and there was a kind of like login page. Sort of like this. And just pretend it's not the case, but pretend that this is over HTTP, so there's no lock. I put in my username, I put in my password, and this button is wired so that when I press it, whatever's in this field, it will open an HTTPS connection and send it over. So I'm not going to send my password in the clear. But the question is, how would you know that as a user? So is there a way to know whether when I click this button, that's going to go over HTTP or it's going to go over HTTPS?
Sometimes on Chrome, if you hover over the link, they will show you the address that it's leading to.
Sure. Yeah. So if this is a hyperlink, then yeah, it could show the address. And in that case, you could look for the indicator, the URL itself, whether it's HTTPS or HTTP. So yeah, so that would work for an expert user. But yeah. So in this case, I'm on Safari and I'm hovering and I don't see anything. Is there any other way I could tell? Yeah, great. So you could look at the HTML of the website, right? So that's like 0.111% of the 0.001% of the population that would do that. But yeah, that's basically what you have to do. Okay. You could also click it, and then because you submit over HTTPS, the next site you get back should be on HTTPS. So you could check and see, but at that point it's too late. So if it comes back over HTTP, too bad, you just sent your password. The other thing that browsers sometimes do is if you do one of these form submits that's not over HTTPS, they might show you a warning. So it's just a generic warning. You might have seen it. It's like, hey, you're about to send something that's not secure. Are you sure you want to do that? So they also did that in responses. But anyway, it turns out there's not a really good way to do it. So this is sort of, I guess, what the website would look like. So you have a bunch of content. You have a place to put your user, your password. You press submit. It is wired to go over HTTPS, but you don't really know it. There's no indicator to the user. What if there was a lock beside the word submit here to show that this is secure?
It's just an icon.
Yeah, exactly. So it's just part of the screen, right? It's just a picture. Anyone can put a picture, a lock on anything. And so that's another thing you used to see too, is lots of locks on websites, but you don't see that so much anymore, like in the content of the website, because they're meaningless. They don't mean anything. Okay, so yeah, if you click submit and the password goes over HTTPS, this is the expected behavior. But if it doesn't, then it's too late. Okay? Now, if there's a web page that's like this, and let's say you're an adversary and you're in the middle, and you know that when the user submits the submit button, it's going to go over HTTPS, right? And you want the password. That's why you're sitting there. You want the username password. Is there anything you can do exploiting all of these things that we that we know about the user experience of this.
You're going to steal his identity, his cookie or his password, just log in as him.
Yeah, so that's what you can do with it. So yeah, so that's what we want for it. So how can we stop it from going over HTTPS?
Forcing HTTPS in the browser.
Sorry, did you say forcing it? So that would be sort of the opposite problem, right? The user would want to force HTTPS, but we want to, in this case, we want to stop it from going over. Is there a way to stop it?
From the attacker's perspective?
Yeah, from the attacker's perspective. So let's say you're in the middle and you see that the user, you know, they request this website, so they pull it down, right? And you know that if they put their username and password and they hit submit, that's going over HTTPS. You want the password, so you don't want that to happen, right? Okay, so what mechanically at a web level, like what is it that makes it go over HTTPS? What? Say louder, sorry. A link, yeah, exactly. So in the HTML, right, this submit button will be hooked up to like a post command or whatever, and there'll be a URL. It'll say, okay, take what the content of this and send it to this URL. And if that URL is HTTPS, then it goes over HTTPS. If that URL is HTTP, then it goes over HTTP. Okay? And so that's in the HTML for this website as it comes down. Okay? This website came down over HTTP. Could the adversary modify it if they're in the middle? Yeah, there's no restrictions on it, right? That's only if it's on HTTPS. Okay, so what if the adversary just was really stupid and all they did is they went through the HTML and everywhere they saw HTTPS, they replaced it with HTTP? Then you would get an exact replica of the website. It would look exactly the same. The only difference is that when you go to submit this button, it would go over HTTP instead of HTTPS. The user probably wouldn't know about it because they're not inspecting the HTML code, right? And you don't even have to know anything about this website. Okay, it's just a generic attack that you can do and you can put on any website, okay? So you could have like a bot that sits in the middle, a middle box, and every time it sees a website go down, it just strips out HTTPS and replaces it with HTTP. So that's that is an attack as well that you can do. So this is called Ssl stripping, and there are softwares that are very generic that do it. Okay, so the adversary in the middle can change the HTML of the page itself. It can change every reference to HTTPS, from HTTPS to HTTP. And now you'll have the exact same website, but it will never leave HTTP. It will always stay in HTTP as you click the links. Okay, now you might like try to send something or fetch something from HTTP that's not available. It's only available over HTTPS. That's fine. The adversary's in the middle, right? So if the request goes out, the adversary can always change it to HTTPS, get the right resource, decrypt it, and then send it over HTTP to the user. So when you're in the middle, you can do things like that. Yeah.
How do they store the new modified HTML into the secure server of the website?
Yeah, sure. So I wish I had a diagram. Do I have a diagram? Let's go back to this diagram. So it doesn't show the attack, but the adversary is basically in the middle here, right? So when this website goes down over HTTP, they do the stripping, okay? And they don't actually have to store it. So they can just forward it to the user without the HTTPS.
They modify the response to put their own HTML, send it to the user, receive it, okay.
Yeah, exactly, yeah. So they replace the HTML. But here it's really simple because you're sending an exact copy of what the news website is sending down. You're just replacing references from HTTPS to HTTP. That's it. Yeah.
Perfect, thank you.
Okay, so yeah, in this case, the HTTP, and there might be an error or something like that, but it's too late, okay? Unless if the browser warns you. So it might give you that generic warning that you're about to submit something. And even that warning, like, is an average user going to know what that means? Or are they just going to click through because they want the website to work, right? So it's not clear what would happen in that case. Okay, I'll show you one last attack. I'll just put it up for a few seconds and you can look at it. Okay, so this has the answer actually here. But anyways, this is just another crazy attack, just to sort of, I'm trying to highlight how broad these attacks are that you can do. So here, imagine you go to a website and the website is controlled by the adversary itself. So you're looking at the adversary's website. So either they're in the middle and they put the website down, or they got you to click on a link through phishing or something like that, okay? So anyway, so you end up on a website that the adversary controls, but it looks like a normal kind of website, like a news website or something like that, okay? And there'll be a login button. Say it's to sign into Facebook. And so let's pretend that you click on it. Then a window pops up, okay? And the window pops up and it says, okay, there's a lock, there's an address, and it would be like facebook.com, https facebook.com, and then there's a place to put your username and there's a place to put your password, okay? So you could enter that in it, all right? Now the problem with this pop-up is you'll notice that just visually it's overlapping the website itself, okay? So the question is that pop-up actually a pop-up from the browser? Is that actually a new browser window? Or is it possible that it's actually an image that's on the website itself? So you click on it and it shows you the image of something that looks like a browser window, but it's not actually a browser window. And then with JavaScript or something like that, you could even make it so you could kind of drag it around and things like that. So I've seen this happen. I've seen it happen in the wild. I've seen it on my Apple where the little window that pops up is like a Windows window. And so you can obviously tell that it's fake. And so it's not always done that well. But anyway, so this would be another thing. If you could put your username and password into it, you're actually sending it to the site itself, right, to the adversary site. And so the adversary would get it. Okay, now, what about this attack? Is there anything that we can do about this particular attack? And so the answer is that browsers, not because of this attack, just because of other reasons, they've moved away from pop-ups, right? So you almost never see a pop-up window. What you might see is a pop-up tab, right? So it will open a new tab with the website in it, but it won't give you the window itself, like a small window that hovers over top. So because of that, because it forces pop-ups into new tabs, then it kind of deals with that particular attack.
You could disable the iframes in the HTML.
Yeah, but this is the oh yeah, so from the browser's perspective, sure, you could do stuff in the browser, but then you're breaking the functionality of a bunch of websites that you normally would go to. Yeah, so that's the trade-off there. Okay, let's move on. Okay, now what I did is I remember way back in the start, the reason we were looking at this is it's interesting to look at HTTPS and it shows you like an in-depth study of the security of something. And you can see that there's lots of different angles to attack it, and you require some domain knowledge. You can't just think up these attacks without knowing what's happening. And you have to look at it in depth. It took 3 or 4 lectures to get through, okay? But anyways, what we can do is we can put this all into an attack tree. So there is an attack tree on the course website. lost the source code for it, so it's like 95% consistent with what I taught, and there might be like 5% that's slightly different because it's based on an older version. We're on Moodle, right? Let me, I'll just go to last year's. Last year's we were just on my website. Okay, so first off, I know you can't read it, but I just have you appreciate how big it is. Okay, so there's all of these different attacks that we talked about. And so the first three kinds of attacks were the knowledge, or sorry, the terminology is slightly different. But basically it's like the idea of breaking into the tunnel itself. There's the idea of what can we learn just by looking from the outside of the tunnel, so like fingerprinting and things like that. And then there's how can we change where the tunnel ends up? Okay, how can we get the tunnel to end with us? And if we want to have it end with us, we could go for a valid certificate, but then we would either have to breach a CA. We could try and subvert the issuance process. So like you might recall from last class, there was all the like email-based authentication, domain validation, and so if you can guess the email password or different things like that, that would be fine. You could do an in-person for the issuing process. You could use the law to try and do it. And interception proxies, we didn't talk about it. It's a different class. We could use just an invalid certificate, so you could just drop it in and hope that users click through. Or you could exploit the fact that there might be a software vulnerability in the browser or the operating system that the user is using. So things like the go-to-fail bug, basic constraints not being checked, like is this an actual CA certificate? The null characters, like those are all examples of implementation errors. You could use a revoked certificate if you can get it, just by dropping the OCSP response, or you could use no certificate like Ssl stripping or picture-in-picture attack. Okay, so this is the most recent things, and then in the past lectures that you watched online, the rest of this stuff was covered. Okay, so what are the broad lessons that we can take away from doing a big attack tree like this? Why did we spend 3 lectures on it? So first off, I want to give you a thorough example of what it looked like, not just a toy example. The main thing I like personally about attack trees is it's very natural to capture non-technical attacks along with technical attacks. Okay, so if the government goes to a CA and says, we want you to use this certificate, right, that's not a technical attack. If you're going to walk into a CA and say, I work at Microsoft, here's my employee badge, even though you were fired 3 months before, that's not a technical attack, right? That's a non-technical attack. If you want to go and break the crypto because it's using RC4 and there's some biases in the ciphertext, that's a technical attack, okay? And all of them end up in the same place, right? All of them give you the exact same thing at the end of the day. They let you spy on HTTPS traffic if you can get yourself in the middle of a conversation. And it doesn't matter if you can do the social engineering attack, it's just as good as doing the crypto attack, right? And so that's the other thing. The adversary doesn't care, you know, and sometimes when you look in academia and you read research, like everyone's focused on like preventing the crypto attacks, right? But then you go in the real world and the real adversaries are doing social engineering or something like that. And so you don't always have this alignment between the two of them. So an attack tree anyways, it lets you put all of the different kinds of attacks. It puts them sort of on equal footing because all of them trace back to that root node, which is the ultimate goal. Okay, attack tree also, it gives you some structure. Okay, you could just have a list of attacks, right? But when you put it in a tree format, then you can see the sort of relationship between them, right? So you can see that, oh, this in-person and this email domain validation, you know, subverting either of them, they're related, right? They're very close. They're giving you kind of the same thing, right? They're letting you subvert the issuance process of a CA, which gets you a valid certificate. Once you have a valid certificate, you can get the tunnel pointed at you. And if you can get the tunnel pointed at you, then you've achieved your goal. Okay, so it shows you kind of the relationship between them. And then it also shows you where there might be gaps, right? Because that's another thing is you want to think of new attacks. And so when you look at a tree like this, you can start to think, oh, is there another attack that's here? Or, you know, I have a valid certificate, an invalid certificate, a revoked certificate, no certificate. Is there any other kind of, like, what about an expired certificate? Like, would there be an attack there? Or what about like some other thing? Like, so when you see the patterns, then sometimes it's easier to see where there might be a gap and you could do something. Another thing is that the tree should tell you a story, right? So I'm going to guess the email password of admin@domain.ca. When I do that, I can subvert the email version of certificate issuance, which is an automated process. Once I do that, then I'm going to end up with a valid certificate. Once I end up with a valid certificate, I'll get the tunnel pointed at me, and then I'll achieve my goal. And so as you walk from a leaf node all the way to the end goal, it tells you kind of a story of how the attack comes together. It's not always the case, but a lot of times it's sort of, sometimes the story is sort of like, okay, I want to do this, what's stopping me, right? Like I want to subvert server authentication, well, I need a certificate, right? So let's say I can get that certificate. Well, how can I do that? Like I can't get that certificate because there's this issuance and they make sure that they only give them out to the right people. Well, maybe I can subvert the issuance somehow. And then, you know, then you can look into the different ways of doing it. And so sometimes it's sort of like there's an attack that you want to do. Here's the defense against it. Then I'm going to attack that defense. What's the defense to that, right? And then you sort of, you go back and forth, and then maybe you realize that down 4 or 5, you know, nodes down this tree that you realize, oh, there's a weak spot here, right? This is a place where you could attack. And once you attack it there, then kind of like dominoes, they all fall. And you go all the way back to your end goal. So anyways, I like attack trees. They're very useful. They're better than just, you know, it's not just random brainstorming. There's a lot of value in doing them in practice. Now the weak side of an attack tree is that this is only one attack, okay? So you spent a lot of effort just to look at that one attack. And let's say you want to look at all the attacks on HTTPS. So you want to look at message integrity or other things. Most of your tree, if you could do a tree for all of them, but then there's going to be a lot that's the same and sort of overlapping and things like that. So it might not be the most efficient use of your time to, you know, do 10 trees for attacking the 10 properties that something is supposed to have. So in that case, you might look at a different kind of methodology. But anyways, if you want to do a really deep dive on doing one kind of attack and all the different ways you could do it, then an attack tree is perfect for the job. Okay, questions about attack trees, SSL, HTTPS, or anything, because otherwise we're going to really switch gears and talk about something completely different. All right, so seeing none, we'll move on to the next topic. Okay, so the next thing we'll talk about is, it's not a methodology per se, it's more like I would consider it a framework. So we're gonna look at one type of attack. The reason I picked this attack is, first off, you've seen it already, so it's gonna be social engineering. And you've already seen it in HTTPS, and maybe we mentioned in passwords as well. But because it's a non-technical attack, it doesn't get the same focus in most of the courses. So you'll take a lot of courses here. If you're doing a security degree, you're going to take lots of technical courses. You're going to learn about crypto and network security and operating security, software security. And so here, what I try and do in this course is at least like pull out a few topics that you're less likely to see, okay? And just because, you know, you take 4 courses on technical attacks and you take 1 lecture on a non-technical attack in one course, that's not like representative of what you would see in the real world, okay? In the real world, there's not 1 social engineering attack for every 100 technical attacks, right? If anything, it might be the exact opposite, right? There might be 100 social engineering attacks for 1 technical attack. Now, because we've been kicking around with technical security for long enough that most systems are pretty good. Attacks get harder. Every now and then there's a new like kind of category of system that comes out, like IoT, for example, and they might make a lot of mistakes because it's new. But generally, if you look at something like an operating system, the level of security that a modern operating system has compared to one 15 years ago or 20 years ago, it's just night and day, right? And if you look at the sophistication of the attacks, you want to get kernel access to an operating system, you have to like chain together like 5 or 6 vulnerabilities, and they're all really complicated, and it only works in this one exact configuration. Those are the kinds of attacks that you need to do. You can answer it if you want. This is our youngest student, by the way. She's off school today. Okay, so social engineering, what is it? So the way I think of social engineering is you're trying to gain access where there's a human that's screening access, okay? So you want access to something, and you can't get access to it without going through a human, all right? Now, it might be implicit or explicit. So sometimes it's literally like someone, like you want to go into a room and there's a security guard like sitting there, and in that case, it's very explicit, right? In other cases, it's not so clear, right? Like you want, I don't know, access to EAS or whatever. Like probably there's a human somewhere that looks at your ticket and then they say, yeah, you can have access, or no, you can't, or something like that. But it's not like in your face. Okay. Social engineering is prevalent, as I tried to hint at. So lots of social engineering based attacks. A lot of the major breaches that we've seen over the last 5 or 10 years have had at least a component of social engineering. So sometimes they're a sort of hybrid attack where social engineering kind of gets your foot in the door and then it moves into a technical attack. I'll tell you lots of stories and give lots of examples in a bit. And there's no good methodology. So the reason I'm not presenting a methodology is because there isn't a good one, okay? There's no, like, how do I protect my organization against social engineering? There's really nothing that you can do other than understand what social engineering looks like and understand the kind of template for the attacks. So what we'll do is we'll look at that. We're gonna focus on the actual template of the attack. I'll use a framework that's from a very good book called The Art of Human Hacking. It's linked on the website. And the book, though, it's more complicated than I think it needs to be, so I simplified the framework a bit. And there's some weird stuff in the book that's kind of like hokey science in my view. So anyway, this will be a kind of stripped down version of the same framework that the author of that book presents. Okay, so here's some just quick examples of social engineering before we go to the framework itself, just so that we know what we're talking about. So we saw validation for an extended validated certificate. You might have to go in person, or at the very least talk to someone on the phone, or maybe you're mailing documents, but someone's reviewing those documents, right? So if you can trick them, then you might be able to get a certificate. Another thing is that, let's say that you want access to a server room, okay? Because once you have physical access, then you can load malware onto the servers or something like that, okay? And so maybe you decide, I can't just walk into the building and get access to it, so I'm going to dress up like I work for the IT company that company already uses, right? And so in this case, I'm sort of impersonating someone, and then I'm going to go in, and I'm going to hope that that's good enough to get past security. Another thing that people do is called road apples. Let's say that you want to infiltrate a company, their servers. What you might do is just throw a bunch of USB sticks around the parking lot, and then employees will come and they'll see it lying there. And what are they going to do? They're going to pick it up, they're going to go into their computer, they're going to plug it in to see what's on it, right? Because they want to give it back to the person, right? They're like, well, I'll give it back to the person who left it, and if there's a file or something on there with their name, then I'll be able to do it. Maybe they're just curious, I don't know. But anyways, that could be loaded with malware, right? And once you stick it in the machine, then now you have malware on the machine. Emails are we all see them, right? And so it could just be like some spammy email, and there's an attachment and there's malware, and if you download that attachment and run it, then if you have the right software installed, you'll lose control of your operating system. It might be that you're trying to get the person to take an action, like give you their credit card number, their social security number, or something like that. And the more common thing that we see that's closer to social engineering is what we call spear phishing. And this is where it's more of a targeted attack, okay? So there's a couple levels of a targeted attack. Someone might look at my email address and say, oh, you're at concordia.ca, that's a university. I'll send you an email that pretends to be from your dean, and I've gotten these emails, and it's like, hey, I'm in a meeting, can you like go buy a bunch of preloaded Visa cards for me? Or something like it quickly breaks down into like something that's absurd. But at first it looks, fairly real, because it's targeted to me, and it's not just some completely random thing that has nothing to do with my day-to-day life. Now, you could take it a step further. Let's say someone really wanted me, right? They could go and they could look and they could say, okay, who's his colleagues, right? Like, who would be emailing him something, Like Professor Manon, he's down the hallway from him. He might send a paper, like a PDF paper, to read, right? And so they might craft an email. They might actually spoof. It's harder now to spoof addresses. It used to be easy. Now there's some technologies called DKIM that protects them. But maybe they were able to actually spoof it so it looks like it comes from that email address, from his email address. If not, they could register something that's similar, right? He sometimes uses his Gmail account, right? So if it was a slightly different Gmail account, 3 N's instead of 2 N's or something, I might not look closely. And if I'm expecting that kind of email and it looks, maybe they use the name of a student, right? An actual real person, right? These are all things that you could look at my website and his website and you could engineer, right? Chances are I'm going to click on that file, right? If it was crafted correctly, okay? So that's the real threat of social engineering, is these highly tailored, not the stuff that's like full of typos, or you click the link and you get some garbage website that's like malformed and that type of thing. We're talking about like real targeted attacks that are coming from the right people, they're going to the right people, they have attachments that make sense with the kind of thing that you might do in your day-to-day life, okay? Those are really hard to actually not click on. The reason we don't experience it is because we're usually not the target of them, right? So yeah. Another form of social engineering is when you call someone on the phone. Often you want to get help, you want to get some resolution to some problem that you have. Customer service agents can have a lot of power, right? So they may be able to do stuff on the back end of the system that substantially change things. Like think of banking, right? Like they might be able to, put a payment through or that type of thing. So they could have a lot of power. If you can trick them, then you could do a lot. Okay, so what do all of these have in common? So they have in common the high-level definition of you're gaining access where there's a human that's screening access. And what I want to say is that they're all going to fit into a kind of framework, okay? So the framework is going to have 3 main stages to it, and not every social engineering attack needs to have all 3. Okay, so most of them, it has to have at least one of them, otherwise it wouldn't be. Most of them have all 3, some of them might have 2 of the 3 or something like that. Okay, so the framework itself is information gathering is the first step. The second step is pretexting, so we'll go through these all one by one. So information gathering is what it sounds like. It's sort of trying to make sure that your attack's going to work. Pretexting is a fancy word for saying that you lie about who you are. Okay, so like when I go dressed as an IT support person, that's a pretext. Okay, the pretext is that I'm an IT support person, even though I'm not. All right, and the last thing is influence. So this is what I'm trying to accomplish. I'm doing this social engineering attack. I'm trying to accomplish something with it. And generally it's one of 2 things. Either I'm trying to persuade the target to do something, I need them to do something, I want them to do it, or I'm trying to get something from them. Okay, I'm trying to get some information. And so it might be slightly different how you approach it. There's obviously a lot of overlap between the two, but you're either trying to persuade them or you're trying to elicit information. And so those are the two subcategories. Okay, so what I'll do is I'm going to show you a little clip from a TV show. So Paul Hagney did this show. It's called The Real Hustle. It's kind of cheesy, I'll warn you, but it actually illustrates a nice social engineering. Paul Hagney's the person that wrote the book that I talked about. And yeah, so in order to do this, I'm going to try and get the sound to go through the... Okay, so let's think about this from the context of information gathering, pretexting, influence, persuasion, and elicitation. Then we'll go through each of these in detail, but this is a nice example. It illustrates at least some of them well. So information gathering, in order to do that attack, what would you have to know about the person, for example, or about the attack before you conduct it? Okay, so the person themselves, they didn't know, right? It was just a random person that they picked. So this wasn't a targeted attack, so they didn't do a lot of background research on that person. Email, did you say? No, you don't need that. Go.
Well, we just need to know that she can be easily distracted.
Okay, sure. So
She can leave her bag unattended for a long enough time.
okay, so you're looking for a target that has the right circumstances. So someone that could be distracted, so they're alone. They waited till the friend went to the bathroom. They had the bag, so that was obviously what they're after. If there's probably wouldn't work on someone that was carrying a wallet as opposed to a purse. So they had the ideal target in their mind. Now, where did they go and find that person?
In the public?
Yes, you. In the food court. Yeah. Why'd they go there? Yeah, maybe because they like food. But a shopping mall is a good place, or a restaurant or something, where you might find someone that's alone with a bag, right? Like there's worse places that you could go to do it. So that's a bit of information gathering. This is fairly minimal because they just chose a random person. Now they also had a bunch of pretexts, right? And so we'll get to the pretext in a second, but you do have to do the background information on the pretexts themselves. They don't work unless if you know what a banker looks like or what a call center sounds like or things like that. So there is some background research that would go into creating realistic pretexts, but beyond that, this was light on the information gathering stage. Okay, so a pretext is when you pretend to be something that you're not. So what's the pretext in this particular attack?
Well, the couple was sitting long before, and then they were pretending to be photoing. And also, I would say that pretexting is when they have this audio files ready for playing it in the phone, and they know how the
Okay.
call center works.
Okay, so first off, note that there's more than one pretext, right? So there's two. So we have the tourists, right? They're sitting, they're pretending they want their picture taken. We have the actual recording itself. So that's not a human pretext. I mean, there's a human that's playing it, but it's sort of a machine-based pretext. So that's two. Any others?
The guy pretending to be working for the bank with the phone ready.
Okay, so there's a guy, he looks like a banker, I think. What do bankers look like?
Suit and tie.
Yeah? Did he look like a banker, Ishana? No? Okay. He looked like a rich guy. Do bankers look like rich guys? Yeah, kind of. They could, especially, yeah. So like a suit, the briefcase, right? It looked like it. He was confident, right? He took control of the situation. It would be hard to say no, right, to someone, especially when you're stressed out about just losing, potentially. Like, think of how damaging it's like you have to go cancel all your cards and you don't have your phone and stuff like that. You want the problem to go away as quickly as possible. Someone's offering you help, right? So there is that sort of environment. He also seemed to have the knowledge of a banker, right? He's like, oh, I work at that bank. It's fine. You just call this number and, they're going to ask you this and then you're going to tell them this. And he sounded like he knew, he didn't give you the indication that he was someone that was faking being a banker, right? And so a lot of it is that those small details there was nothing really about that performance where you would maybe doubt that he was. Now, something he didn't do that he could have done is business cards are a completely meaningless piece of authentication, right? If I have a business card that says Concordia, it doesn't, I mean, I could get one that says McGill or Waterloo or whatever. Or you guys could get them that say Concordia, that you're faculty as well, right? Like anyone can print a business card. Yet people they treat the business card almost like it's a photo ID or something like that. So imagine that he doesn't know who the victim's going to be. So he doesn't know what bank she's going to be at. But that's fine. You could have 5 business cards. They're all like kind of stacked with all the 5 major banks, and she says, I'm at Barclays, and then you pull out the Barclays card and give it to her, right? And like think of how legitimate that would seem. Okay. Then what we can do, so that's the banker. So we have the tourists, we have the banker. So there was the automated system, right? It sounded like an automated system, it had the robot voice and things like that. So that was one. And then there was the person that was on the call center, right? That was pretending. So that would be the 4th pretext. And so in this case, what made that realistic? Did that sound like a call center? Was there any elements that made it more realistic or less realistic? Okay, so the background noise was a nice touch, right? Call center people kind of have a certain way of talking to. It's kind of scripted, automated. It sounds like they talk about the same problems all day, every day for 8 hours a day, and they're kind of bored, but they're friendly. And so he sort of matched that, right? And so, yeah, once again, it's the little things that if you get them wrong, then it just leaves room for doubt, right? And that's what you don't want to do from a social engineering attacker's perspective, is that you just want to leave no doubt about what your pretext is. Okay, now the influence in this case was elicitation. So they were trying to learn the PIN number, right? So it was they physically got possession of the card, right? That's relatively easy, right? There's lots of attacks you can think of to get possession, physical possession of a card, but getting someone to tell their PIN and voluntarily, that's the other thing. Okay, so no coercion, right? They were voluntarily told the PIN, and the person would leave the situation not knowing that they gave their PIN to the wrong person, okay? So they would be naive. Now, maybe 2 days later, 3 days later, they will figure out that it was a scam, right? But it's not like overt coercion where when the person's leaving, they're like, oh, I just got scammed, right? And so those are the aspects of the attack. Yes?
How did he know it was a scam?
So the person didn't know it was a scam, so that's the point.
Then how at the end he was like, I just got scammed and stuff.
Oh, so they told her at the end, yeah. So they had to tell her in order to. Just because it's ethical, right? So that's another aspect of social engineering, is the ethics of it. And we'll talk about that, right? And so, yeah. Okay, so in this case, you want to do elicitation. And there's maybe some aspects that worked, that made it work well. So the first thing is that this was a stressful situation, right? So she was stressed about losing her purse and her phone, and so you sometimes will abandon like logic or critical thought when you're in those types of situations. Okay. The banker projected confidence. He had at least a quick fix for at least canceling the cards. Ideally, she'd like to get the purse back and get the cards back. But she's thinking, I have to go to the bank now and like cancel them. And there's someone that's standing there. They're giving you like just a phone call. They even dialed the number for them. That type of thing. You just talk to someone. At least that you can check that off your to-do list now that your purse has been stolen. And so it was a very smooth, frictionless thing for her to fall into. So that helped make it easier to persuade her to give her PIN. The other thing is you could think of the counterfactual. So let's say that, put yourself in her shoes, right? So you're now, after this course, you've taken the social engineering, and so you would never put your PIN in that. But like, how do you get out of that situation? Like, you'd have to basically offend, like there's someone there, he's trying to help you, you think he's a banker, and you have to be like, oh no, like thanks, but I'm not going to take your help. I'll go talk to the real bank, right? Now this is one position where maybe a mall isn't the best situation because there's a chance there's a branch of that bank in the mall itself. So it might actually be very easy. If you could do it in a situation where going to a bank would be there'd be more friction there. That's a subtle thing that could help. And so, but anyways, you are putting someone in a situation where they have to potentially offend someone that's trying to help in order to do the right thing, right? So that just adds a little bit more pressure to the situation. And then the fact that he didn't ask her the PIN either, right? And the call center person also didn't ask the PIN. She just typed it into the phone. I feel like there's maybe something subtle there where it doesn't make any logical sense, but it seems easier to give your secret to a computer than to a person, right? It seems like it's safer somehow. But of course, it's not any safer, right? If you give it to the computer, anyone who runs the computer now knows it, including the humans. And so I like that aspect of it as well. So anyway, those were a couple notes. Yes?
Makes no sense.
It makes no sense. Thank you.
The person that asked for a photo is the person that's on the phone. So how did she not recognize the voice of the scammer?
Yeah. I'm not sure your question, actually. We'll talk about this offline, okay? Okay, so anyways, everything I just walked through, I wrote out, so it's in the notes. Does anyone have any other ideas about information gathering, pretexting, or influence that I didn't cover?
I think it has to be quick, and they need to influence a person in a state of panic so that she doesn't get time to even understand that there might be scam going on. Because actually, my friend who studies cybersecurity, she got scammed by phone.
Yeah, it happens.
But she wasn't she was panicked because they told her that her SIM was compromised, not SIM, bank account, yes.
Yeah.
Her bank account was compromised, and she had to give the PIN to cancel the bank account or whatever. So
Right.
she was super.
Yeah, you're flustered, but then there's the time pressure as well. Yeah. So pressure is something that you can put pressure on someone, but you can't put pressure on them for 24 hours, right? Or 7 days or something like that, right? Pressure is something that's temporal. Eventually you acclimatize yourself to the pressure and your emotions go back, right? And if you want to look at a biological level, there's a lot of, it's hormonal, the different aspects of stress, and your body just can't produce those hormones for so long, right? So there's a certain time gap. And so if you can jump in that time gap, it's good. Okay, one last question before we go to break.
Okay. I almost got scammed 2 times.
Yeah? And what happened? Tell us about one of them.
I was playing Roblox with my friend, and then I got a text on my phone, and it said Canada was giving me $210. And then I got really excited, but then you told me it was a scam.
That's right. You asked someone that is more knowledgeable.
And then it happened a second time, but I knew it was a scam.
Yeah, that's right. Good example. Good example. All right, let's go for a 10-minute break. So come back around 7:10. It's only half over.
Wait, can I put this down?
Yeah, come over here. Come around. The other side.
This?
Yeah. input.
What the? How would you work from here?
I'd have to stand.
This cool. That good. Can I draw something here?
Yeah. Did you like the video?
Yeah.
Yeah, it was good.
That's what that is.
What is it? NH? Hi. How are you? Sorry, say it again.
My certified exam is there today.
Is today?
Yeah.
Okay, okay.
So our names.
No problem, no problem. Good luck with it.
Okay, thank you. So any some important tips my if you know.
Sorry for the exam.
Yeah.
Sorry, which is it? It's the CEP. CEH. Certified Ethical Hacker. Yeah. I don't know. I've seen students take it before, but I haven't looked at the material itself. So yeah. I'm not sure. And it's online or? Okay. Yeah. I don't know the curriculum, but anyways, let me know how it goes and what the questions are.
Yeah. Next lecture.
Yeah. Perfect. Okay. Good luck with it. Yeah.
I'm sure you must have seen this video.
Oh yeah. That's you. Yeah. Sorry. Yeah.
So I mean, if you really want, I can make the one document for the QX private key.
No. I just.
No, because I just wanted to make it clear because there's a TA that's evaluating the projects.
Yeah.
She might not be aware, he or she.
Yeah. So my question to you, I think you didn't quite get, but did you use that in your assignment, like the fact that it was a private key as opposed to a public?
I only used the public one. So before 29th of January, it was public, right?
Yeah. Sorry. So it was public. Did you point that out as a vulnerability in your stride?
Yeah.
Yeah. You did. Okay. That's all. That's
whenever
what.
it was asked,
Okay.
yeah.
Well, we didn't ask about that explicitly. So.
Oh, no, then.
But it would fall like there would be a potential attack because they use their public key instead of their private key. And so I was just wondering if you uncovered that as an attack or not.
Well, I can assure you that whatever was asked in the assignment one, previous one, all of it was addressed.
Yeah.
Completely.
No problem.
If that's something that you're asking for.
No. I'm just saying that I just think it might not make a difference. Like it was changed from public to private. It doesn't really make a difference to the question, and your answer might look the same with it. So like it won't even come up.
Because I'll be very happy if you ask me to submit another one with the private as well.
No. Like it shouldn't change anything. Like it was just a typo, and it probably has no impact on your answer.
Okay.
That's what I was trying to ascertain was if you answered in such a way that actually had to do with that small typo, then it might be a problem, but probably you didn't. So anyways, the TA knows now. Maybe she forgets or something like that. When you get the assignment back, if you feel that like a mark was deducted because of that confusion, then just send me a follow-up and I'll take care of it.
And when is it we're gonna have to submit our project?
Assignment two.
I think the project is open right now because you've already said what one has to be done.
Yeah.
On the very first class.
Exactly, yeah.
So,
And assignment two will be released after reading.
so I'll be looking into the papers, I guess, because I think I've already asked you in the introduction class that I'll be using my own published paper.
Right.
But then I think you said it would be much better if I go on some other ones. Yeah.
Sort of, yeah. So you want to do something new, so you can put a new spin on it, or because you have all the background knowledge from that paper, you should leverage that, but you should still do something new.
Sure.
A new spin or something. Cool. Okay, you're welcome. Yeah.
What's the normal number? Total and number.
Who the heck is Lopez Blanco Max?
Look.
Nice.
Right away over.
Soon. Another 3 minutes.
You said during the break you're gonna go to the office.
Yeah, it's fine now. I'll just go with it.
What are they eating?
What is it? Banana? That's a banana. I don't know what that is.
They're not banana. They're mac and
Oh,
cheese.
mac and cheese. That is, but what's in the bowl? It's so weird looking. Is it pasta?
Maybe it's chicken.
Maybe it's chicken.
Sauce. I don't have the internet password.
Oh yeah, can you give me your computer? I'll put you on it. there's nothing I can do, okay? I can't keep everyone waiting just for you two. Who's your phone? Okay, we'll start. So I didn't go back and get my tablet. I think this works fine. All right, so now what we'll do is we'll go through the 3 stages in depth. And then next class, I'll tell you lots of more stories about social engineering attacks. So information gathering, pretexting, influence, persuasion, elicitation. Okay, so the reason that we're studying social engineering, I've already said a few times, it's very prevalent. So it's a common type of attack. What I'm going to try and give you is the intuition for how it works. It's hard to defend against. It's hard to write down a set of rules. If you just do this, then you won't be vulnerable to it. And so the next best thing, if you don't know how to defend against something, you at least need to understand what the attack is and how it looks and what the components are and understand enough about the attack as possible. So that's kind of the stage that we're at with social engineering from an academic perspective. Another thing is you can actually get a job doing social engineering. So companies will hire people to go in and try and breach using social engineering attack. It's kind of like penetration testing, but at the human level as opposed to the network level. One thing that you should keep in mind is that most social engineering is illegal. And even if it's not illegal, like strictly by letter of the law, it could be highly unethical as well. And so in particular for the people who are doing social engineering, it's important that you negotiate the sort of boundaries of what you're going to do before you actually do it. Let's say you go into an organization, an employee makes a mistake and then they're fired as a consequence of you doing it. You have to, there's nothing illegal about that, but you have to think through the ethical implications, right? So are you going to tell the employer like a rundown of all the employees and what they were vulnerable to or not? Or are you just going to give them sort of high level, like you might want to look into this area because some of your employees, without naming names, there was a problem there, right? And so that's the sort of, anyway, you have to think through these particular issues.
Professor,
Yeah.
I participated in a social engineering exercise for a company.
Yes.
We had 2 teams. Like people would go into trying to connect a USB in a public agency.
Okay.
Also the phishing emails. For the phishing emails, we would do something without names. We would just gather the statistics for the attack, who opened the link, who clicked on the file, or whatever, with trackers.
Right.
With the other one, they would actually go with a permission card signed by everybody so that they could perform the in-person attack. And if anything, they had like the exercise and stuff about it.
Yeah, that's cool. That's cool. Yeah, and that's another thing too is that, yeah, if you do these types of attacks, you need some sort of documentation about who you are so that if you have to blow your cover or like you're about to get arrested or something like that, you can try. It might not be enough, but anyways, yeah. Okay. All right, so let's go through them one by one. Okay, so information gathering. What you're going to do is you're going to go and you're going to learn first off about who the victim of your attack is going to be. Okay, so it could be a company or a person inside of a company. It might just be a person in general. And so the more you learn about that person, the better. The other thing is if you're going to use a pretext, you also have to learn about your pretext, right? And so you have to be able to play the part for your pretext. Okay, so if you want to learn about a company, first off, you can do a lot of like stuff just from the web itself. Okay, so you can search for the company. You can look at the company website. You can go to the About Us. You can try and figure out the org chart. You can get names of employees that work there. You can go to social media, so LinkedIn in particular for learning the organizational structure of a company is useful. You can learn what people's titles are and make guesses about who's boss and things like that. And so that's all like kind of publicly available. There are some tools that help you automate this process. So like Multigo is probably the most popular one. And so this is an open source tool. It's kind of weird to use. I've tried to demo it in the past, but it's you have to get all these modules and things like that to plug in. But basically, it could do something like it could scrape LinkedIn. You give it like one person's profile, and then it pulls in all the information automatically, and you don't have to do it manually. Another thing you can do is you can do what's called password profiling, where let's say you are in a situation where you want to try and guess a password. You can try exhaustive search, so that will work, but you could tailor the exhaustive search to like key terms or words or things like that that might be more likely. So if it's some sort of work-based password, maybe they use the product name in the password or something like that. So what you can do is you can point a profiler at the company website. It will just go through the entire website and take out all the words, right? And then it will build its exhaustive search dictionary using those words, or having a higher weight on those kinds of words as well. So it's not guaranteed, but it could shave some time off of those types of attacks. You can also see people chatting with each other on social networking. You can learn what people are interested in. So this might help you with either a pretext. It might help you, like say you're doing some sort of spear phishing. You could say, hey, like, here's a chance to win, and then give them something they would actually want to win, right? Like tickets to, a Montreal Impact game, right? Because you know that they're into soccer, or, here's an exclusive thing to this restaurant that's like their favorite restaurant that you know from social media or something like that. Or we know that you frequent this restaurant, and so now we want to do something for you, or whatever. And so anyways, you can use interests to your advantage. Another thing that's really important when you look at employees and you're looking at a company and you're trying to look at an entry point into a company is vacation plans. Okay, so what are people's vacation plans? This is something that you could gather from social media, especially when they're in the middle of their vacation, or you might learn about where they intend to do it. So why are vacation plans so important? So what happens is when someone goes on vacation, when they go on leave for any reason, so it could be a parental leave, it could be a vacation, it could be because they're sick, it doesn't really matter. But their job, they have a job, right? And they're good at that job because that's the job that they do, every day, every work day of the year, right? Now, when they go on vacation, someone else has to do that job. Okay, that person, that's not their normal job, probably. Sometimes you have like more than one person that does the same job and they're all kind of replaceable. But there's other positions where you're going to pull someone and their job is something completely different, and they're going to sit at that desk and try and do that person's job for a week while they're on vacation, right? And what happens here is you have a disruption in the chain of command, right? So the procedures that someone follows, right? They know them very well because they do it. The people they interact with, let's say an IT person comes in, or someone dressed in an IT uniform, and you're the person that's sitting at the desk, right, in front of the server room, right? You know the people, right? You know the people that come in. But if that person's on vacation, there's someone else sitting on the desk, that person doesn't know the normal people, right? They don't know what the uniform looks like, right? And so there's an opportunity there where you might be able to exploit the fact that they don't know the right protocols or the right people. All right. Now, sometimes, though, it can backfire and you can get the exact opposite, right? Sometimes because the person is new to the job and they don't know the protocols, then they're really going to follow those protocols to the letter, right? Because they're scared of screwing up, right? And so in that case, they might even be more particular. Whereas the person who normally sits, they bend the rules in certain circumstances because it's convenient, and they bent the rules for some time as well, okay? So you don't always know what you're going to get. It's not a guarantee that because the right person's on a vacation that you'll be able to step in. But it's an interesting, very useful piece of information that you can think about. So the chain of command temporarily changes, and then you can target the temporary replacement. So they might not know the protocols, they might not know the people, or conversely, they might follow the rules more carefully. Now, similar to this, you can also use other kinds of disruption. So this is basically, it's just a disruption where the regular rules aren't followed. And there's other forms of disruption as well. So for example, it might be some physical thing like construction, right? So if you think about physical access to a building, right? If you wait until there's a period of construction, there's probably lots of people going in and out of the buildings. There's doors that maybe are normally locked that are propped open because the real door that you would normally go through, you can't go through anymore. And so there could be all sorts of rearrangements of like sort of the layout, physical layout of a company. Emergencies, another thing, the fire alarm goes off, power goes out, that type of thing. Then what does it look like, right? Are there certain doors that are open that normally wouldn't be open, or that type of thing? Another thing that you can that's useful for information gathering is dumpster diving. So this is where you're going to go and you're going to look at the garbage that's produced by companies. Now companies are very particular about it. So this isn't as profitable. It might be profitable against a small kind of business, but against any large kind of business now, we know about the importance of the documents that get thrown out. And so either there's private companies that come in and they take especially the paperwork away, or they shred them, right? And often there's still a private company that comes in and takes the shredded documents itself. But in earlier days, companies would throw out all sorts of stuff, right? So things with phone numbers, you can learn who their customers are, who their contractors are. You can learn salaries, budget information, maybe even username passwords, like maybe IT prints them out, or you get a new computer and there's a piece of paper stuck to your monitor with the default username and password, right? And then the person throws that in the garbage, but they don't change their password, that kind of thing. So anyways, now just because a company lease this out, that could also be an opportunity for a pretext, right? So you could show up and be like, okay, I'm the person from the company that shreds your paper, and then walk out with all the documents instead of shredding them as well. Okay, questions or comments on information gathering? Stories, anything? Okay. All right, so the next thing is pretexting. So pretexting is basically you pretend to be someone that you're not. And pretexting isn't a social engineering attack in itself. Okay, like your job isn't to get someone to believe that you're an IT person and then you're like, okay, I just did this attack because they believe me. It gets you close to what your ultimate goal is, okay? So your ultimate goal is to get access to someone, persuade someone to do something, get some piece of information or something like that. So a pretext isn't the whole story of a social engineering attack, but what it's meant to do is try to get you in closer proximity to what your actual goal is with the pretext itself. Okay, so there's a good set of examples that come out of a social engineering book. So we can not look at all of them, but there's a bunch of different pretexts that you might use. So like a temp worker or an employee, internal IT support. So we didn't really emphasize it, but there's a lot of internal things that you can do. So you can pretend to be someone internally. You can, so some of these like tourist, girlfriend, boyfriend maybe doesn't work so well. This could work like if you're showing up to visit a particular person, you want to leave something. Any kind of service that they might farm out, pest control. This is the kind of thing like it's weird, right? Like it's something that you wouldn't see. It's not like they're coming, hopefully, right? They're not coming once a week or once a month. And so they don't know who you are, they don't know what the company is, or that type of thing. So yeah. Yes, Ishana. What's one?
A delivery person can be a delivery person just so they can get like your address and everything, and then they quit their job so then they can get all your information.
Yeah, that's right. So you could pretend that you're working for FedEx or Amazon Prime.
You get a job at that place.
Yeah. So you could. So the pretext doesn't have to be something that you do temporarily. Like you could actually literally go out and get the job in order to do the pretext. And in that case, it's kind of real, and then you quit after the attack. So that's sort of the longer route, but it does happen. Yeah, that type of thing. Okay. In terms of making a good pretext, somehow the Zoom here got messed up. Oh well, hopefully that's still readable. The software updated and now I don't know where anything is. It's got to be in the menu somewhere though. Yes, Shoshana? Okay, here we go. Thanks. Okay, maintaining a good pretext. So become an expert is one thing. So you want to actually, like, to the extent that you can, actually know the pretext. So like if you're an IT person, that's your pretext. There is a chance that you'll be asked to do something, right? So you're going in because you want access to the server room, but the person's like, oh, before you go in, like, can you fix this for me or something like that? And you can always try and blow them off, but anyways, the more you know about it, it's only going to help. Confidence is also important. So you don't want to give a window of doubt to the victim. Another thing that social engineers do is they'll script out the actual possible conversations that they might have. So they're going to open with this, and the person's either going to say this, or this, and this is what their response is going to be. They're not doing it to memorize it or to sound scripted when they talk. You obviously want to sound natural, but it's just to try and think out where all the possibilities are, and it helps with your confidence because you sort of know what you'll say in different situations. You have to have an exit plan. I don't know if I wrote that explicitly, but like there are certain things where you might just need to leave, right? And so what is it that would trigger that, and at what point are you willing to just throw in the towel and say, you know, forget this, I'm just going to abandon it? And could you leave in a graceful way or leave in a way that doesn't leave the person doubting who you were? And so those are things. So the more you can script out and sort of role play what might happen, the better probably the interaction will actually go. Another thing to recognize is that lying takes brain power, right? So you're thinking about your lie, and so you're spending half of your brain on that, and then you only have half a brain left to think about, like, how are you doing, and what is it that you want, and what's the conversation that I'm having, and things like that. First off, some pretexts would be easier than others. And another thing you can do is record everything, especially interactions where the goal is elicitation. Just record it, go in, have the interaction, get out, and then you can go and listen to it and see what was actually said. Or, you know, if someone tells you a password or something, you don't try to memorize it, right? You just record it. Small details are important. So every little detail can add to your, just basically it goes back to like trying to eliminate doubt, reasonable doubt from the victim, right? And so there's little things that you could do that could be subtly wrong that they're not going to blow your cover necessarily, but they're going to get the person starting to doubt it, right? And once they start thinking about it, then yeah, it just leaves room. Then they think about it more, and then maybe you have a problem with it, okay? So like uniforms, for example, like the smallest detail, like as close as you can get it to the real uniform would be good. You can look at equipment that you might carry. So if you're an IT person, like what do you have with you? What are you carrying around with you? Do you have like an Ethernet like thing to like strip Ethernet cables and stuff? I don't know. So like those are the types of things. How you talk is important. So the words that you use. So if you're an expert in IT, you're going to talk a lot about like Cat5 and I don't know, like stuff that like, yeah, you have your own specific jargon. There's regional concerns as well. So is this a job that's somehow tied to the local region? Do you have the right accent for it? You know, the right, so not just the jargon, but how you articulate words and things like that. And so there's lots of other small details as well that you can consider. Okay, any comments on pretexting or questions? Yeah, so jargon just means like technical terms, not everyday terms. The word jargon itself is jargon.
Is more like building the faith in the target.
Yeah. So that we'll get into a little bit later. So that's how you influence them, is try to build confidence. But right here, it's just about not leaving any room for doubt, essentially. Okay. Then for influence, it's basically the same for whether you're eliciting information or you're persuading, but there's a few small differences that might come into play. But the commonality is, you have the goal, you know what you want, you're going to do as much planning ahead, you're going to work on your pretext, you're going to work on your information gathering, you're going to have a contingency plan, so if everything goes wrong, and you're going to have an exit plan for how you're going to get out of the situation. And you're going to exploit whatever disruption is possible. So construction, people on vacation, that type of thing. Okay, so for elicitation, what you're trying to do is you're trying to get information that shouldn't be disclosed. Okay, so somebody knows something, they shouldn't tell you what it is based on who you actually are, but you're going to use perhaps a pretext or some other persuasion technique in order to get that information from them. So one thing that helps, which is the point before, is if you build a kind of rapport with someone. So rapport means like they're confident, they're friendly, they like you, that type of thing, right? So if you can get the target to like you, you tell jokes, maybe you express some mutual interests, right? So this can go back to the information gathering stage. So you know that they're a fan of something, and obviously you don't want to just bring it up out of the blue, but if there's some natural way, like maybe you see something on their desk and you point it out, and then you're like, oh, I really like the Montreal Impact too, or whatever. I keep saying Montreal Impact, it's actually CF Montreal now. But anyways, that's how much of a fan I am of them. So anyway, so you can express mutual interests. You can flatter them, right? Appeal to their ego, that type of thing. That also can work as well. Another thing you can do, this is sort of reverse psychology, is you can go and you can actually say something wrong that you don't know the right answer, but you know a wrong answer, and you just say it as if it's the right answer. And humans love to correct you, right? If you hear someone, the sales figure for last quarter was blah, 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 and it's completely wrong, and I know the answer, I'm going to be like, no, it wasn't. It was like this, right? Like even before I realize what I'm saying. And so anyway, that's one small trick that you can do. Another thing is with your information gathering, what you can do is you can start disclosing things to the victim that you already know, okay? And they're going to assume, well, if you know all of this already, then what's the harm in you knowing this extra information, okay? So especially if you can get some information that's proprietary or not just anyone would know, then yeah, you're sort of like a safe person to disclose information to. And sometimes elicitation happens in stages where you gather up information to do this with someone new, and then the information they give you, you do this type of thing with someone else, and so you sort of build up this body of knowledge until you get to the actual victim that you want to attack. Another thing that's just a small thing is there's this concept of preloading. So preloading is you can start getting someone to think about something just by kind of sprinkling it into the conversation. So if I, really want to have sushi, like tonight, I might like tell my wife, like I might mention it offhand or something like that, or not even like in the explicit, reference to going out to eat. I might just like mention it or something, like somehow, I don't know how, like I was trading Bitcoin on Sushi Swap or something, and which is an actual name of an exchange or whatever. So you just sort of sprinkle that idea. It gets the person thinking about it, and then they might be a little more open to an idea that you have, or to talking about something or things like that. Persuasion, it's very similar. In this case, instead of trying to get information from them, you want them to do something that only they can do. So they're the ones that are authorized to do it. So you need them to do it. Building a rapport also works. So that's a common thing. Another thing you could try and do is build empathy. So empathy would be they feel sorry for you, right? You're like, like say you show up for a job interview, right? And you're like, I had such a bad morning. I had to take my kids to daycare and drop them off, and it was raining, and I had my resume, but I left it. It was in my bag. My bag was open. It got soaking wet. And could you just please print off my resume? It's on this USB stick. It's just cv.pdf. Could you just do me this favor and print it off real quick from your computer, right? So that's something that someone might do if they felt empathy for your situation, right? Maybe they have kids themselves and are in a similar situation, right? There's also indebtedness. So you could be like, you walk in and they're on Facebook or something. People don't use Facebook anymore. They're on Twitter or TikTok, and and you're like, your boss is coming around the corner. You better get off of TikTok. And so they close it down, and then they feel happy about that. And then you ask them, oh, could you print off my CV? They might be more inclined to do it because you sort of did a favor for them, and they'll do a favor for you. So that's the idea of indebtedness. That's not the best example, but that's the sort of idea. And so these are things where you could try and get someone to do something, either because they feel sorry for you or because you did them a favor. Another technique, so this is like typical sales marketing type of thing, is if there's something you want, you can ask for a lot more than what you want, and people will say no. Like if you ask for it, they're going to say no. So you can ask for a lot more, they'll say no, and then you can sort of try and fall back to like, well, maybe a compromise is you could just do this small thing for me. And that small thing is actually what you wanted all along. So that's another technique that sometimes works. Emotional manipulation, first off, that's subject to ethics, right? So you have to think through the ethics of what you're doing. If you're doing this in the context of a job, there's going to be guidelines, right? You can't just go in and start yelling at people or scaring people half to death or things like that. But if you can put them in emotional states, the victim, then you can, make it easier to persuade someone to do something. Okay, so it could be fear, it could be anger, it could be anxiety, it could be coercion. These are techniques. So ethical hacker is not going to do this usually, there's going to be a lot of red tape around what they're allowed to do and what they're not allowed to do. So let's just say they don't do it. But obviously, in a real world, a real attacker won't have any problem doing this, right? They'll do it. Okay, any comments or questions about persuasion? Okay, so I'll tell you a couple stories. Okay, so the first story has to do with RSA. You might have heard of RSA. It's a famous encryption algorithm. There's also RSA, the company. And so they're related. So it's a large security company. So this concerns the company, not the encryption algorithm. They have a big conference every year called the RSA conference. It's kind of the biggest event in security from a corporate perspective. And does anyone know, I guess we talked about it in passwords, but since you weren't in person, does anyone know what RSA often, what's one product you might actually have from RSA?
The keychain that with changing number to double factor authentication.
Okay. So if we go back to passwords, an alternative to passwords is two-factor authentication. So in two-factor authentication, it asks you for your username, it asks you for your password, you put it in, and you've successfully passed that step. Then what it will do is it will send you a number, right? So it might text it to you, it might email it to you, or in particular, like maybe not as popular now, you might have like a keychain, and the keychain has a number on it. Like it has a little LCD screen and it rotates through the numbers. And either you click on it every time you log in to get a new number, or every 5 minutes it updates, okay? So how does this actually work? Like what's the technology that is behind it? So basically what will happen is you'll go and you'll log into a website and it'll say, okay, I need 3 things from you. I need your username, I need your password, and I need whatever is the number that's on your current like keychain device, okay? So you type the 3 things in. Then generally what it will do is it will go to like the website that you're logging in. So let's say you're logging in for work. So Concordia has a server. Concordia has my password, right? So they have my username and my password, so they can do that check. But Concordia doesn't necessarily know what's on my RSA thing. They could set up a server, so there's different packages that you could buy from RSA, but the easiest one is you let RSA handle that themselves, okay? So what they know is they do know the serial number of the thing that they gave me. So if all of us in the room have an RSA token, all of our tokens will have a different number at the same time, okay? So they're all unique. They all have a serial number, so it's sort of registered. And so Concordia will know, oh, I gave Alice this particular serial number, okay? So what it will do is it will talk to RSA and it will say, RSA, okay, so Alice is trying to log in, you know, whatever, her username password's correct, but I'm not sure about this number. So here's the serial number of her token, and can you tell me whether or not this is the number that should be displayed on her screen at this particular time? And then that server will say yes or no. If it's yes, then you log her in. If it's no, then you don't log it in. Okay. Now the final question is, how does RSA know what's on the screen? Okay, so RSA made the token, but it keeps updating every 5 minutes. So how do they know what's on the screen?
They follow,
Go ahead.
they follow a mathematical process with a seed number that keeps mutating with basic algorithms.
Okay. So when you take cryptography, you might learn about pseudo-random number generators. But basically what it is it's a function that spits out random numbers, but it spits it out in a deterministic way. So it starts with a seed, and if you have 2 pseudo-random numbers with the same seed, they'll spit out the same random numbers in the same order. Okay, so we call it pseudo-random. It's not truly random. A truly random function, if you started them both off, they would spit out different numbers, right? So this is pseudo-random, meaning deterministic, but it looks random. That's why we call it random. So it's pseudo because it's deterministic, but it's random because it actually statistically looks random. It's hard to predict. You're not going to guess it. The seed is too long to guess, so you can't do an exhaustive search on the seed. And so you're kind of stuck if you're trying to attack it, if you're trying to predict what these numbers are going to look like, okay? So what happens is RSA keep a copy of the seed. So they have a database that has the seed. They put the seed on the device and the serial number on the device. And every 5 minutes, the device will run the pseudo-random number generator and get the next number. Okay, then 5 minutes later, we'll get the next number and the next number. And on the server, RSA is doing the same thing. Okay, every 5 minutes, they're updating the number on the RSA side. Now, technically, that's a bit of a lie, because RSA, they don't actually every 5 minutes have to go and update the number. Because they know the algorithm, they can just fast forward to what the number should be. So that's actually what they do in practice. Is it's not that they have to actually update it every 5 minutes, but they can figure out what the number should be based on what the current time is and what the seed was. What was that number that it started from? Okay, so they're sitting on this database. The database has the seed in it so that they can generate the random numbers that match it. And sometimes there's slight synchronization issues, like maybe this lags by a tenth of a second, but over a week, a month, a year, right, the windows start slipping. So if the number's not the right number, they'll look and see, oh, was that the number in like the previous 5 minutes or the 5 minutes after, and they'll kind of resynchronize and things like that. So it doesn't have to be precise science in terms of the amount of time itself. Okay, now if you were able to get the seed from RSA, so RSA has all the seeds for all of these things, if you're able to steal them from RSA, then basically the token's useless. Okay, so that's all you need, is you need this seed file. So RSA is going to protect this file. It's going to be one of their biggest secrets. It's kind of like the root key to a certificate authority or something like that. There's going to be heavy protection on it. They're a big security company. They should know how to secure it. And their clients are also usually people that demand high security as well. Okay, so like a lot of government, U.S. government, military, those are the types of people that would contract out and use these RSA tokens. It's not something that like no one, I don't know if anyone has one of these. Maybe depending on where you work, you might have one. But it's not a typical thing, right? It's usually when you go into a company and they're very serious about security, that's when they're going to spend money on these, because it costs money, right? You have to set up the server and pay RSA, and then you have to buy all the tokens and provision them and stuff like that. So it's not free.
Nowadays they also use applications like apps with a changing number instead of the physical.
Yeah, exactly. Yeah, so that's a better way of doing it. Is you can do it, and then Google can offer you essentially the same thing like Google Authenticator for free, and so lots of companies would switch. But but government still is largely fixed RSA for reasons like you have to get audits of companies before you can use them as government, and that process takes a long time and things like that. So RSA kind of have this privileged position. Okay. Okay, so how could I break this second factor? So let's say I can lift your password. I have a keystroke logger on your computer. So I have your username, I have your password. If I don't have your token, then I can't log in as you. So that's why it's better than just having a password. So two-factor is giving you something. So I could steal your token. That would be one thing, right? A physical theft. Or what I could do is I could try to steal all the seeds off of RSA server, which sounds like an impossible task, but it actually was an attack that took place. Okay, so attacker was able to do this once, and it was a humongous problem, right? Like, think about it for RSA. So first off, they got basically all the seeds for like all the tokens. So RSA had to recall all the physical tokens themselves, reprogram them with new seeds, send them back. They're a security company, right? So it's just embarrassing in general that they would have this high level breach. And they had a lot of high profile clients as well. Now, it wasn't quite the end of the world, because even if I have the seed file, I probably don't have the password, right? So I reduce two-factor authentication to single-factor authentication. But unless if I have that password as well, then I'm not getting into the system that I want to attack. So that was the only thing that sort of saved it from being a real colossal failure, is that you still had the passwords protecting the accounts themselves. Now, what's less known about this attack is that it actually was a social engineering attack, at least the way it started. Okay, so what happened is the adversary went and they did a bunch of research on RSA, the company. Maybe they worked there. Who knows? No one knows who they are or why they did what they did. But what they were able to do is they were able to identify a small team of people, real people that worked in HR at the company, and they all worked together. And what they did is they did an email, okay? And the email was from one HR person to 3 or 4 other HR people, and it was very natural for these people to be exchanging emails, okay? So this isn't your run-of-the-mill like spam phishing email that you get. This is a highly crafted email that's sent to exactly the right people. It's from the right person, or it looks like it's from the right person, and it would be natural that these 4 or 5 people would be included in an email thread. The email from address was spoofed. So this attack was a little while ago when it was easier to do this type of thing. So when you received the email, it looked like it actually came from the actual person. It wasn't like a copycat email with like a different letter or something like that. And it was a malicious attachment. And so the malicious attachment was 2011_recruitment_plan.xsl. Anyone know what XSL is? What's that file extension? If I open it, what application opens up? Excel. Okay, so this is a spreadsheet in Excel. So this looks very natural. It's the kind of file that you might expect, HR people to pass around. You might expect an Excel file. And another thing too is an Excel file, that's just a spreadsheet. That shouldn't be dangerous to open. Like there's some files, like if you get a .exe, right? If you open that, like it's going to execute, like, you should know better than that, right? But if you get a .mp3 file, right? Like who cares? Like what's the chance? It's not like it's going to start running code, right? Like maybe it opens in your MP3 player and there's some exploit in the MP3 player. That's like the only way that you could get, you could get a breach based on opening an MP3 file because it's just data, right? A spreadsheet is kind of like data, at least it seems that way, but not when it's Microsoft Excel, right? So when it's Microsoft Excel, they like to load it up with all sorts of fun features. And so one of their fun features is that, hey, wouldn't it be cool if you had cells that could like execute code? And you could write like a little Flash script, and so whatever you put in this cell, it would like run, or ActiveX, or like whatever Visual Basics, whatever Microsoft's like chosen thing is. Yeah. And so anyway, so this one had an embedded Flash script in the Excel file that was malicious. So Flash is a programming language. You might not remember it. Hopefully you do, but it's been kind of scrubbed off the web. And so, but anyways, the point is that this is executable code. So it's actually going to execute. Yes? I know, it's kind of sloppy. I'm sorry. Okay. And the other thing about it that makes this not just a run-of-the-mill attack too is that there was an actual zero-day exploit. So zero-day means that it was never seen in the wild before. So it wasn't like they went out and they found some exploit in Excel, they made a malicious file, and then they hoped that they hadn't patched that version of Excel. These people knew what they were doing. They had an exploit that no one had seen before. This was the first time that it was seen. And so, and it basically exploited Flash in Excel and was able to do some privilege escalation. And they were able to install malware on the computer of anyone who looked at the attachment. Okay, so this gets the malware onto one computer of an HR employee. And from there, we don't know the details. So RSA didn't really talk a lot about what happened. They put a blog post up initially that sort of explained up to this point, and then they took it down. And it's linked to from the Wayback Machine on the course website. There was a Wired article that came out like 10 years later, and it's like, oh, this thing happened 10 years ago. Here's what actually happened. And I think I read it, but I don't remember the details of it. But anyway, so I'll just fast forward past the rest of it. So this is absolutely not trivial at all. But somehow they were able to, with that toehold in that one computer, they were able to then start a technical attack where they were able to spread through the network, and they eventually ended up on the target machine that had all the seeds on it. So on the server that had all of these. Okay. Now they're not quite done. So let's say you're able to get malware on this server. Your malware now has access to all the seeds, right? So that should be game over. But your malware is not you, right? Your malware is running on their server, and it has access to the seeds, but you're not on that server. You're outside of the network. Okay, so there's another step in attacks that is often forgot about, especially by academics, which is exfiltrating the data. So you got to get the data back out of the network, and there's all sorts of intrusion detection systems and things like that that look for just anything unusual, right? Like you open a port to a random computer and you start dumping gigabytes of data, right? That looks funny, and so the system will just jump in and close it. Just give me a minute. Okay. And so there was another whole aspect of the attack as well, where they they spend a lot of time like engineering a way to exfiltrate this data in a way that wasn't going to trip off the intrusion detection systems and things like that. So once again, there wasn't a lot of details, but it was just mentioned as one of the features of this particular attack. But anyway, so there was this very super serious attack that happened, big consequences, and it started from a malicious email. Yes.
This is the longest story ever.
Thank you. Thank you. You're not coming to class again.
We got a world record for longest story ever.
Okay, I'll tell an even longer one. All right. Dude, they're exciting though. You like the stories? No? All right. Okay, so here's another one. This one happened close to us in Ottawa. And so someone set up an exchange service for Bitcoin. Bitcoin's a cryptocurrency. I do a lot of research on that. You don't have to know a lot about how Bitcoin works to understand it. But let's say that you have Canadian dollars and you want to buy Bitcoin with it, or conversely, you have Bitcoin and you want to swap it for Canadian dollars. An exchange service is basically someone that's going to do this for you. And in order for them to take your Bitcoin and take someone else's Canadian dollars and swap them, they actually have to have both of those things in their custody. Okay? So they're not reaching into your wallet and pulling the money out because they have no technical way of doing it. So if you want to use an exchange service, what you have to do is you have to move your Canadian dollars out of your bank account into the exchange service, into their bank account. And they'll say, we owe you that money back, right? Like here's a dashboard of how much we owe you. They'll have a withdraw method where you can pull your money back out and they'll send it to your bank account or whatever. And sometimes they're fraudulent, right? So that's one concern. In this case, it's a legitimate exchange service. And then same with the Bitcoin as well. So the Bitcoin, you have to move it into the custody. So send it to the address of the exchange, and then the exchange basically will swap it with Canadian dollars. And then when you withdraw, you'll withdraw based on your new balance. Okay, so what exchanges do is they end up sitting on a lot of Canadian dollars, and they'll sit on a lot of Bitcoin, right? Basically, all the users that are exchanging at a particular time, they all have it sitting on the server. And so what the Bitcoin is particularly problematic. So if someone were able to take over the server that's running this exchange, they would be able to pull the Bitcoin off. They could pull the Canadian dollars out, but then you have to use the banking system, and the banking system tends to be reversible and traceable. So even if they were able to instruct do a transaction from this account to this account, then the bank someone would find out, they would complain, and the bank would go and reverse it, right? So even though you got the money out, you would owe it back. And you would have to like sign up for an account and give your identity and things like that. Your Bitcoin though, that's a totally different scenario, right? Bitcoin you can just digitally steal. You lift a key, it's not traceable. There is some traceability to it that we can get into. Take 6630 if you want to learn all about Bitcoin. But anyways, let's just assume that it's basically not traceable. It's not reversible. And so if you're able to pull it off of the exchange, then there's basically nothing the exchange can do about it. Okay. So exchanges know that it's risky. It's a risky business to be operating in. So what they'll do is they'll not keep all of their Bitcoin on their server. They have to keep some because people at any given time want to withdraw their Bitcoin. So they have to have some sitting there, but they can have some other that's not sitting on the server itself. Maybe it's on a USB stick that's stored in a safety deposit box at a bank or something like that. Okay, so generally we call it a hot wallet is the money that's sitting on the server itself, and then the cold wallet is the thing that's sitting on an air-gapped computer or on a USB stick or something like that. Anyway, so this is an exchange. It was in Ottawa, and they had their hot wallet that was sitting on their server, and they weren't hosting the server themselves. Okay, so instead of them, having the server sitting on their own premises, what they did is they went and they contracted it out. So there is a company called Granite Networks that's owned by Rogers. Rogers is the big telecom, I'm sure you know. And so they have a big data center, and you can go and you can rent a locker in the data center. You can put your server there and run it, and then they'll maintain it and make sure that it's always on and give you uninterrupted power and all of that kind of stuff. Yes.
I made a story about scanning on my computer.
Okay, you can tell that after class, okay? All right. So you, so anyway, so they had a hot wallet. It didn't have a lot. This was a pretty small exchange. So like most exchanges would have way more money than that, but it's still a material amount. They had about $100,000 worth of Bitcoin sitting on the server itself. All right. So basically this money got stolen in a social engineering attack. So what the adversary did is instead of targeting the exchange themselves, they targeted Granite Networks. They thought, if I can get physical access to that machine or virtual access, then I can drain it of all of the Bitcoin. And that's sitting on the premises of this company, right? And so I'm going to try and trick that company into thinking that I'm the owner of the server, that I'm actually from the exchange. And so that's what they did. So they contacted customer support for Granite Networks. And in this case, they didn't call them or go in person. They actually just used the web chat. So there's, you know, on websites how there's that little chat box that pops up and you can ask things. That's all they did. They just opened it up and they basically said, hey, we're from this exchange and you have one of our servers and we're having problems with it and we're wondering if you can help. And amazingly, Granite Networks didn't do any authentication at all. They seemed to just assume that probably so few people asked for help, and this person knew that the exchange was a legitimate customer, and that seemed to be enough. They seemed to be convinced immediately that, oh, this must be the right exchange, right, that's asking for it, because who else would ask for it? And so what they did is they asked for, so they asked for access to the servers. They gave minimal information. So this is pulled out of a news article, so it's hard to get all the details. But basically, it seemed to suffice for them to just say that they work for this exchange, which is a legitimate customer of Granite Networks. And then we're not sure exactly what they asked for. So the news article said that they asked for a computer to be plugged into the server. And they also said that they asked for it to be rebooted into safe mode. So normally you would reboot into safe mode because it turns off like all the security protections, like the firewall and all of that kinds of stuff. So between those two actions, I don't know exactly how it worked, but basically they got remote access to the server, and they just drained it from all the Bitcoin from the hot wallet. Okay, one last story. Yeah.
Is it easy to know which company is hosting for a specific website? How would they know who to chat to or know if they're AWS, Azure, or any other? Is it easy to do?
Yeah. So in this case, I'm going to speculate, so I don't know for sure, but I assume that by co-locating with them, their IP address ended up being Granite Networks. So it probably was as simple as just looking at the IP address and then doing a who is and figuring out that Granite Networks owns it. Yeah. I think that's, or looking at the IP, who the IP address was allocated to. So I think that's it. Yeah, you can ask your question while I open my slides. Okay, one last story. All right, so this is a guy, Matt Honan. He's a journalist. This was written up in Wired Magazine. Where I got it from. Just let me do this. And the thing about Matt Honan is he had a Twitter account, and his Twitter username was @Matt. Okay? And @Matt, if you know anything about Twitter, in the early days of Twitter, you were limited to 140 characters, and that included the username of anyone that you wanted to talk to. And so short usernames were very desirable. So people liked short usernames. So @Matt is very short, right? Three characters. So someone wanted to steal this Twitter account from him, okay? So if you want to steal this Twitter account from Matt, what would you do? Phishing, one. Okay, any other ideas? Something even easier.
Stolen
Right, we got a right answer. Okay, reset password. That's the first thing that you could at least try, right? Hi, I'm at Matt. I forgot my password. What is it? So that's what the adversary did. So they did a password reset, and Twitter said, okay, no problem. We have your Gmail on file. We're going to send a link into your Gmail. Okay. Now the attacker has a problem because they don't know the Gmail password, right? They want the Twitter password, and it's redirecting them to Gmail. So what do? Say it loud.
Oh, he gave them his email and everything.
Nope.
Try other options, maybe phone number or.
Okay, so let's say there's no other option. It's literally just the send an email to Gmail.
Oh, reset password for the email.
Okay. So then what do? We go over to Google and we say, hi, I'm matthonan@gmail.com. I forgot my password. Okay. So they go there and Google says, okay, great, no problem. We'll reset your password. We have a secondary email on your behalf. Okay. The secondary email is @me. Does anyone remember what @me is? Okay, so this was Apple's like attempt at social media that failed very badly. So it was like they tried to do Facebook and it failed, and so they had all these like me email addresses. Okay, so now what do? Same thing, right? So now we're going over to Apple, and we say, I have this @me account. I forgot my password. I want to reset it. Now this is where the story is a little different, okay? Apple is an e-commerce site, okay? And so, because they have iTunes store where you can buy things. They didn't have the App Store. This was a while ago, but they had iTunes and things like that. And so they actually had people's credit cards on number. You couldn't pay Google or you couldn't pay Twitter for anything at this point in history. So Apple says, okay, we'll reset your password. We have your credit card on file. So just tell us your username, tell us your billing address, and tell us the last 4 digits of your credit card, and we'll go and we'll reset your password for you. So the person knew the username, that was fine. The billing address, they said, so Matt Honan had his own domain name. So they just said, whoismatthonan.com or whatever it was. And the whois record had his home address. So they assumed that the home address was the same as the billing address, so that's fine. But then they were stuck at the last 4 digits of the credit card. So they didn't know what those were, okay? So then what they did is they said, okay, where can we get the last 4 digits of the credit card? Well, maybe Matt Honan uses Amazon. Okay, let's try that, see what happens. So they go over to Amazon and they say, I'm Matt Honan@gmail.com or whatever it is, and I forgot my password. Okay, now Amazon also a little bit different. They're an e-commerce site. They also have like humans that will talk to you on the phone. Okay, so what he did is the adversary, I think it was a he because Matt Honan ended up talking to him after and asked him how to do the attack. That's why we know these details. But the attacker said, I'm Matt Honan, I want to reset my password. What do I need to do? And Amazon basically says the same 4 things, or same 3 things. We need your username, we need your billing address, and we need the last 4 digits of your credit card. Okay? So that was a roadblock. So he hit a sort of stop. There's no more accounts to reset or anything like that. All right? But then the attacker has a brilliant idea. Okay? So the attacker hangs up, and then they call back Amazon and use a different voice, or they probably get a different customer service agent. And they say, okay, I'm Matt Honan, and they don't say I want to reset my password. They say, hi, I'm Matt Honan, and I want to add a credit card to my account. Okay? Now Amazon, they're kind of sketched out when someone says, I forgot my password. Am I dealing with the right Matt Honan? Like, oh my God, like I don't want to just reset a password, right? But you call up Amazon and say, hey, I want to spend money with you. I have this credit card. I want to add it to my account, right? And they roll out the red carpet and they're like, yes, please. Like, what's the credit card number, okay? So they say, let me add a credit card to it. And all they need is the account information. I just need your username. I'm not going to ask you anything else. I'll just believe that you are. And really, what's the harm? Maybe you're not Matt Honan. Maybe you're someone else. And that person's adding a credit card to Amazon, and then I'm going to charge that credit card instead. Like who cares, right? Okay, so that's great. So they add credit card 2. Then what they do is they hang up again, and they call back, different accent, different voice, and they say, back to the same story. I'm Matt Honan, I forgot my password. All right? So they say, okay, no problem. We just need your username, we need your billing address, and we need the last 4 digits of your credit card. So they know the username, they know the billing address. What about the last 4 digits of the credit card? Okay, so they don't know the original credit card, but they do know the second credit card because they just added it to it. And Amazon doesn't know the difference, right? It's just last 4 digits of any credit card that's on file. And so they tell them, and Amazon says, great, we're going to reset your password, right? Then the user logs in to Amazon, and Amazon doesn't show them the other credit cards that are on the account in their full glory. What it does is it stars them all out and shows them the last 4 digits only, okay? Now, what was Apple asking for? Okay, so then they go back to Apple, and they say, kind of your username, billing address, last 4 digits, and Apple says, and they say, here's my last 4 digits, just 1 sec. And they say, great, we'll reset your Apple password. So they do that. Then they go back to Gmail and they say, I want to reset my password. And they say, oh, no problem, we'll just send an email to Apple, which the adversary now controls. And so Gmail gets reset. Then they go back to Twitter and reset the Twitter password. It says, we're going to send an email to Gmail, which the adversary now controls. And so they reset the Twitter password. Okay, now I'd like to say that this is where the story ends, and it more or less is, with one exception. The attacker, they really wanted to cover their tracks, so they didn't want to get caught. And so as they kind of went up the different services, what they decided to do was to erase things as they went. So when they reset the Gmail, they didn't just reset the password, they wiped his entire account. Now, he's a journalist. He has lots of contacts. He has lots of emails with people. And so he basically lost all of his work because of it, okay? When they reset the Apple password, Apple had a feature where, first off, it's an iCloud password, so it covers all sorts of things, right? For example, it covers your phone, right? So your phone has an iPhone account. Apple has this feature called Find My iPhone, and they also have a reset so that if you ever lose your iPhone, then you can reset it and it wipes all the iPhone. So the adversary hit that button. And so he lost his iPhone. He lost all the files on it, all the pictures, and basically everything that was in his iPhone account. And then for a very small window of time, basically changed because of this story, Apple loved the remote wiping thing so much that they actually had it in their computers. So your computer, if you're logged into iCloud, you can have this feature where if you ever lose your computer, you can do Find My, and if you realize that someone else has it, you can remote wipe it. And so the adversary remote wiped his computer. He lost everything. He lost like his wedding photos, photos of his kids, all his files. Like think about everything that's on your laptop, plus everything on your phone, plus everything that's sitting in your Gmail account or whatever you use, right? And then boom, it's all gone, right? And so yeah, so this was as it was a huge consequence to his personal life. And anyways, he ended up talking then because the person had reset these accounts. He could just send emails to the account or DM the Twitter account. And so he ended up talking. He said, "I'm a journalist. I wanted can you tell me how you did it so I can help protect other people?" And then the adversary told him basically how to do it. And if you want to read the whole thing, go read the Wire article because it's really good. So that's it. One last question. We're over time.